this is a shell method problem. The revolution axis, I put that at x equals to 10. X equals to 10 is a vertical line, so we have a vertical revolution axis. The integral is a dx integral. So we have three function y equals to x to the third, which is a curve, y equals to 8, the blue horizontal line, and x equals to 0, the vertical red line. And then rotate about x equals to 10. So before we start, if you use a this or washers method to take care of this problem, this will be a dy problem. So let's take a look at the formula of the shell method. So the formula in the integrand, you will see that I wrote 2 pi r times height times dy or dx, right? So the 2 pi r is the base of the rectangle. Let's just look at the two-dimensional rectangle. The 2 pi r is the base, the h is the height, so 2 pi r times height, you get one two-dimensional rectangle. And then when you consider the dx or dy, you consider the thickness. Once you consider the thickness, the 2D rectangle becomes a 3D rectangle. So that's how we got the shell method. And then how big is the object? The lower limit is a, the upper limit is b. So let's start finding the radius. So how do you find the radius? So when you find the radius, you have to draw a rectangle first using the midpoint rule. So we draw a point right here, and then we take that as a midpoint, and then another point right there, and then we line this up. So now we have a rectangle. So this is my rectangle. The radius is what is the distance between this rectangle and the revolution axis. So to find out, I have to use the right minus left, which is the what? The 10 minus x. So this is x equals to 10 minus any x in the region. Or you can treat the rectangle as x. So you take 10, subtract any x, or take 10, subtract the rectangle. So 10 minus x is the radius. So let me draw the radius for you. So this is the radius. So that is 10 minus x. And then the next thing you have to figure out is the height. So the height, we will be finding the area. So that is the top curve minus the bottom curve. So top minus bottom. The top curve is the blue line, 8. The bottom curve is the third power, x to the third power. So in detail, this is y equals to 8 minus y equals to x to the third. And then you set up your integral. So the volume is integral. X goes from where to where? X goes from 0 to where? The 0 is here. So what about this mark? So to find out that mark, the intersection is y equals to 8, right? So y equals to 8, that is equals to the cube root of x. So we know that x is equals to 2. So this point must be equals to 2. So therefore, this is x equals to 2. That is the intersection. And then you have 2 pi times r. R is 10 minus x. And then the height is 8 minus x to the third. And then this is a dx integral. So that's how you answer this question. So let's don't waste the graph. Let's do a what if. So what if, so let me switch to another color. What if I change my revolution axis to here? The pink one. How about x equals to negative 14? How does that affect the radius and height? So when you find the radius, this time, so the radius is going to be right minus left. So this time will be any x subtract the negative 14. So this is any x in the region minus x equals to negative 14. What about the height? No change. So the height is still the top minus bottom, which is 8 minus x to the third, no change. And then you set up your integral. So the volume is integral. X goes from 0 to 2, and then you have 2 pi r x minus negative 14, and then times the height, 8 minus x to the third dx. That's how you take care this what if. So if you think one problem is not enough, let's do one more. So the next problem that I prepare for you is right here. So this time I have a parabola and a straight line. So we have a region bounded by the parabola and the straight line, and then we rotate about x equals to 6. So first thing first, this is a vertical revolution axis. So we have a dx integral to set up, right? And then you have to find the radius. So the radius is where? The distance between the rectangle and x equals to 6. Where is the rectangle? Let's draw the rectangle. So take a point right here and then take a point right here. Take that as a midpoint. And this is how we get the rectangle. So which one minus which one? We always use right minus left, which is 6 minus any x, right? So any x. So this is x equals to 6 minus any x in the region. And then what about the height? The height will be top curve minus bottom curve. So top minus bottom. So the top curve is the parabola minus x squared, and then the bottom curve is 3. So you just subtract 3. You don't need a parenthesis. This is y equals to 4x minus x squared, and then minus y equals to 3. So now the setup is done. And then we put everything together, but we need a lower limit and we need an upper limit. So we need this x and then this x. How do we find them? So in order to find them, you have to set the two functions equal. So let's use another color to do this. Let's use white. So this is x and x, right? How do we find that? We have to set them equal. So 4x minus x squared, that is equals to 3. And then we have to find x. I want to keep the x positive, so therefore I would put all the terms to the right. So this is x squared minus 4x plus 3 equals to 0. And I am lucky, this can be factored completely. X minus 1 times x minus 3. And then x is equals to 1, x is equals to 3. So now I can erase the x and then put x equals to 1 and x equals to 3. And then you go back to the integral. So the volume is equals to x equals to 1 to x equals to 3. And then we have 2 pi, the radius, 6 minus x, times the height, 4x minus x squared minus 3. And then dx. Now the job is done. Let's do a what if. So what if I put a revolution axis at x equals to negative 1? Pick a number for me. How about negative 5? So x equals to negative 5. So this time we have this rotation, x equals to negative 5. How does that affect the radius? So this time when you find the radius, this radius is going to be right minus left. So this will be any x, subtract the negative 5. Any x. So any x in the region. And then minus x equals to negative 5. And then the height, no change. It's just the top minus bottom, no change. And then when you find the integral, you have v, that x goes from 1 to 3, and then you have 2 pi r x minus negative 5, and then times the height, that is 4x minus x squared minus 3, and then dx. So to evaluate this integral, you can take the 2 pi out because 2 pi is constant, and then you have to fully open up the two factors and then combine the like terms, simplify the like terms, use simple power rule to integrate, and then use fundamental theorem of calculus. You will get the result. So this is the what if. The revolution axis is x equals to negative 5. So 2 big problems. That should be enough for you, right? So if you think the instruction is helpful, let me know in the comment below. Like the video, share the video for me, subscribe to my channel if you haven't done so. Appreciate your help and support. See you all in the next one. Signing off for now.